Laptop computers are measured according to the diagonals of their screens. So it's not the sides or the base, it's truly the diagonal. So across the screens. An 18-inch laptop has a screen that is 9 inches tall. So we've got a laptop. There's the screen. And they said it's an 18-inch. So that means this is 18 inches. And they said it is 9 inches tall. Right? How wide is the screen? So what is it from here to here? Well, we just created with that diagonal 2 right triangles inside there. So I can ignore this one and use just these 2 numbers to find my base, to find the width of the screen. I'm going to do that first using the Pythagorean theorem. And we'll label this as A. 9 squared is equal to 18 squared. 9 squared is 81. 18 squared is 324. Subtract 81 from both sides. A squared is equal to 243. Now we have to take the square root. We're not looking for exact or approximate anymore. We're looking for the width of the screen. So the square root of 243 is 15 point, round answers to the hundredths place, which is the second decimal. So my test digit is 8. My rounding digit is 8. Because the test digit is 8, I add 1 to my rounding digit. So 15.59. This is a word problem, so I would say the screen is 15.59 inches wide. The next question is, what is the area of the screen? Well, we needed to know what this was in order to find the area, because you cannot use the hypotenuse to find area. And area is going to be equal to base times height divided by 2. My base is 15.59 times 9, and divide that by 2. Clear your calculator and use 15.59 times 9 divided by 2. And I got 70.155. So we're going to do 70.16. Now, this is area. The area is 70.16 inches, but it's area, so it has to be squared. Okay. A cable is installed around 2 edges of a rectangular field, right? So we've got a field. And they're saying that cable is installed around 2 edges. All right. 860 feet long, 340 feet wide. All right, suppose the cable cost $2,100 per foot to install. Round answers to nearest hundredth. How much did it cost to run the cable along the 2 edges? Well, what's the total cable run? We just add these up. 340 plus 860. So 1,200 feet of cable was run at $2,100 per foot. A little bit of conversion here. 1,200 times 2,100 is 2,520,000. $2,520,000. Don't forget your unit. How much did it cost? It cost that much to run the cable. Okay, the next question is, how much would it have cost to run the cable along the diagonal? Well, we need to know what the diagonal is. And the diagonal is from here to here. Now this creates this is a right angle here, so I'm looking for C. $340 squared is 115,600. 860 squared is 739,600. You need to add those. 855,200. And lastly, take the square root of both sides. And that's 924.77. Going to round to anything hundredth. So 924.77. And this is feet. Now, that's the diagonal. How much will it cost to run that? Well, we just need to convert feet to dollars. And it's $2,100 per foot. So clear a calculator and go 924.77 times 2,100. And it's going to, it would have cost, it will cost $1,942,017 to run the cable diagonally, to run the cable diagonally. And then lastly, how much money would you have saved, would have been saved if the cable were installed along the diagonal of the field instead of around the edges of the field? Well, how much money would have been saved? You just subtract the two. So 2,520,000 minus 1,942,017. 2520000 minus answer equals, and $577,983 would have been saved by choosing the diagonal. Okay. One more. Two trains leave a station at the same time. Train A travels south at a rate of 25 miles per hour. Got a representation here. Train B travels east at a rate of 20 miles per hour. How far apart are the trains 6 hours after they leave the station? I am not going to do this one, and I'm not going to give you this on the exam. I've never done these before. Not in this class. This is not one we do. So I'm going to stop the video and we'll pick you up on circles.